Hello everyone. Today we will continue to talk about the topic 2 instructions. In today's class, we will focus on two sections, 2.6 logic operations and 2.7 instructions for making decisions. And again, you are required to read the corresponding material of your textbook in order to get a better understanding of the material that will be delivered in class. So first, we will focus on the logic operations. Let's try to recall what we have learned until now, what type of operation we have learned until now. So I want to pause here to think by yourself and then compare with, what I mentioned here, whether it is matched with what you answered. Okay. So I think the first we have. Let me make it bigger. Until now, we have learned arithmetic operation, include add, sub, and the immediate operation, include add immediate, and also we have learned data transfer operations like store word or load word. Okay. So we also know to represent the arithmetic operation in machine language, I need an R format. And to represent add immediate in machine language, I need I format. In order to implement the data transfer operation, I need the I format. So in today's class, we will learn another type of operation called the logic operation. Okay, and this logic operation will learn the following few types: shift logic, okay, and bit by bit AND logic, bit by bit OR logic, and bit by bit NOT logic. Okay, and here I want you to know directly all those logic operation can be represented by R format as long as it not include any potential small constant. Similar to the add immediate, if they include a certain I format such as or include the small constant such as AND immediate or immediate, and in the future we learn other type. For those ones, we will represent I format. The reason is because by carrying the small constant in the instruction itself, we save the energy or the time required to fetch the constant in the register profile. Instead, they will carry this instruction will carry this small constant in their immediate field directly. Okay, so I hope this is clear to you, although we not really talk about what exactly is shift logic, what exactly is AND logic, what exactly OR NOT logic, but here is kind of overview what we have learned and what we will learn. Okay, so now let's go back to the original slides. So shift, right? So shift logic, which show as here, you can shift to the left and you can also shift to the right, right? Therefore, the shift logic include two types. Shift left logic, which represent as SLL, okay, and shift right logic, which represent as SRL. Okay, so basically we fill in here, this shift logic include shift left logic and shift right logic. And then bit by bit AND, we include AND 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 immediate. Okay, so here we already actually here is represent. And also bit by bit OR logic includes or immediate, which I already show here, or immediate. And the bit by bit NOT logic, this one actually a little bit different. You said bit by bit NOT, right? So if based on the representation from the previous for logic, you will show the right as a NOT here. But here, surprisingly, they use NOR as the instruction notation. So basically, instead of using NOT, they're using NOR as the notation, although the main purpose is represent NOT. So why it is not like the other ones, to represent using not directly or using instead we're using nor. I want you to, ask yourself this question. Try to think a little bit and carry that question for the following of today's class. We will answer this question together. All right. So now we will talk about this few logic operation individually. The first, we will talk about the shift operation. So just want to make sure the time is not too long. Okay, thank you. So we said we include two types: shift left logic and shift right logic, right? So let's try to, like I already show here. So let's, try to figure out how to write this shift left logic by using the assembly language, and how to write the shift right logic using assembly language. Let's try to figure out by ourselves. Okay, I already tell you, right? The shift left logic or shift right logic is representing by using R format. If you recall, we said the MIPS32 has a very strict regulation on the assembly language representation, right? As long as it can be represented by R format, it always is an operation, destination, first source operand, and the second source operand, right? So if we try to, say I want to do, okay, shift the content included in T0 to the left by, let's say, 5 bits. Let me make it smaller so they can represent nicer. Okay, so I said, right, all the R format will be operation, continue with the destination operand, first source operand, second source operand. Okay, so and then I want you to implement this operation, shift T0 to the left by 5 bit, and store the results, let's say in TS0. Let's say this way. Okay, I want you to pause here and also now to look at the slides and try to figure out, how to do that by yourself first, and then compare with what I'm saying here. Okay. So, okay, so let's go back. So we said, right, the first is operation, the second will be destination operand, so there will be S0, and then will be first source operand will be T0, and then will be second source operand will be 5. So I can represent shift left logic by doing this. Without, looking into the, textbook or slides, I can figure out that. The reason is because MIPS32 architecture has a very strict regulation for the representation of the assembly language. Okay, so similarly, I want you to do a little example. Okay, so I want you to do the shift the content in S1 to the right by 4 bits and store the value or results in T2. Okay, I want you to pause here, try to figure out how you represent this high-level operation by using assembly language shift right logic. Please pause here and try to figure out by yourself and then compare with the solution here. Okay, so basically I will be the operation and then followed by the destination and followed by the source, the first source operand, and followed by the second source operand, which is shown as here. Okay, I hope it's you get the general idea here. And then now I will try to think. Okay, so first I want you to compare with here. You can see this is what we just say how to represent the shift left logic, right? Shift the value in S0 to the left by 4 bit and then use that to update T2. That is this example. And I think I didn't list the shift right logic, but it's the same. Okay, so now let's try to figure out how we let's see here. how we represent this shift left logic or shift right logic by using the machine language. Okay, we said the shift right logic and shift left logic both using R format. Please try to answer by yourself how to represent R format, how many segments included in R format, and what is the meaning of each segment. I want you to pause here and try to answer by yourself, and then continue with this video to compare with your answer and the answer I give.